Hello everyone, here is example on chain rule. Chain rule is one of the main subtopic under derivatives. So let us see one function. Let us take one function on chain rule. First of all, before we apply chain rule, two or more function might be combined or composed each other. What means combination of two function? It might be either of the four mathematical operation, plus, minus, times, or divide. That means two function or more, they might be combined by plus or minus. So the derivative of f plus or minus of g is the same as f derivative plus or minus g derivative. Separately, we can derivate and the outcome will be the same. Okay, the derivative of f plus or minus g is the same as the derivative of f plus the derivative of g. This is rule number one in case of combination. Again, still in case of combination, if two functions are combined by multiplication operation like f times g, the whole derivative, it's going to be f derivative g plus f g derivative. This is again another rule. This is product rule, we call it product rule. What does it say? The first function will be derivated and multiplied with the second, plus the first function as it is multiplied with the g derivative, the second function, in case of product. So somehow unique rule in case of multiplication. So this is product rule, still combination. The third one, division or quotient function. F over g derivative, it is the same as f derivative g minus f g derivative over g square. This is quotient rule, we call it. The numerator, as you see, it is the same as like multiplication, but the middle operation here it's minus, and the denominator will be squared. All of these are, we call them combination, because all of the functions are combined each other by either of the mathematical operation. But in case of composition, it's not like combination. Composed function means two or more function might be composed each other. Because you can see one example. For example, let's say our function f of x be sine of, okay, ln of the square root of x squared plus 1. Consider this function. This time we can see around 4 function. Okay, let's write it again once. Let's take a function f of x. F of x, let it be sine of ln of the square root of x squared plus 1. We can take this function as one function, but they are composed each other. How many functions are there? There is sine, again there is ln, and there is a square root, and finally there is quadratic. So here around 4 functions are composed each other. They are not combined by plus or minus or times or divide. They are composed each other. So this is trigonometric function, this is logarithmic function, natural logarithm, ln, and square root function, there are also quadratic function. So how to derivate? How to derivate this kind of function? Do they have their own rule? Yes, that rule is said to be chain rule. So let us see the process. The process, we will start derivating from the outer function. So f derivative of x will be, the outer function here it is sine. So the derivative of sine is cos. Cosine of the whole thing, ln of the square root of x squared plus 1. Nothing is changed here. Everything as it is. Only the sign is derivated, as you see. But we will continue for the rest. Times. Now next, ln function. But every one of you here, remember the ln derivative. Ln x derivative, if you forget it, ln x derivative is the same as 1 over x. That is a rule. So recalling this, the derivative of ln will be 1 over of what? 1 over of the whole thing, that is the square root of x squared plus 1. Times, I will continue. Now square root function. Remember again, radical x derivative mean it's 1 over 2 root x. So using this rule, now the next function is a square root function. So the square root function is 1 over 2 times, what is the square root of the square root of the whole thing, x squared plus 1. Still times x squared plus 1 derivative will be 2x. After this, it's going to be simplification only. But till now, what did I do? First, I derivate the trigonometric function, then the logarithmic function, then the square root function, then the quadratic. Here is the logarithmic function derivative, then the ln derivative, here the square root derivative, this one the quadratic function. So when you simplify, you can cancel 2 by 2 here. And then when you multiply here these two denominators, the radical will be removed. But the above one, x and cosine will be left, cosine of the whole thing. Okay, let us see now the final result. The final result will be f derivative of x will be x cos ln of the square root of x squared plus 1 the whole over the denominator function. When you multiply square root of x squared plus 1 with itself, it will be x squared plus 1. So this will be the final answer. We cannot simplify further. Here there is one common mistake I'm observing. Students, they are trying to simplify this with this. Impossible, because this one is composed one together. This is separate function, so we cannot do anything here. So this will be the final answer. So you can see the process from above. Here is the example. The functions are sine, ln, square root, then quadratic. When you derivate, first sine derivated and the remaining as it is, the whole as it is, and then ln derivated, it will be 1 over of the function, then square root derivative 1 over 2 times of the square root value, then the quadratic derivative x squared plus 1 will be just 2x. Then simplified, final answer will be, as you see here, it is simplified and written. This is x squared. So thank you for listening.